Welcome to Algebra 2 with Mr. Clausen. Today we're going to talk about algebraic equations, and specifically I want to look at more real-world applications that we can use with algebraic equations. So with that, specifically what I'm going to look at is setting up algebraic equations given specific ratios or proportions, and then I want to look at a harder real-world application problem. So with that said, let's get started here with some of the examples. So skill 1, let's set up an algebraic equation using a given ratio or proportion. So in this given situation, they say one side of a triangle is 1 inch longer than the shortest side and 1 inch shorter than the longest side. The perimeter is 17 inches. Find the dimensions of the triangle. Okay, so they're giving us a triangle here, and you really have to pay attention to the wording here. This is a challenging problem, and I'm going to walk you through it step by step. But one of the things that they're doing here is that we're looking at this and we're going to say, all right, we're given side x here. We have to assign something to base our conversation off of. So they say one side of a triangle is 1 inch longer than the shortest side. Okay. So just from perspective of my triangle, we're just picking a side. This side looks shorter. So I'm going to say this is the shortest side. And so one of the things that we want to learn how to do here is that if this is just a side and this is 1 inch longer than the shortest side here, what I can say is that this side is equal to x minus 1. Okay, and so what I'm trying to do is I'm trying to create my own algebraic equation to go and describe a situation. And I can say that this is x minus 1 because this is 1 inch shorter than the shortest side. And the same thing can be applied to the other situation where it says, and 1 inch shorter from the longest side. Okay, this side is the longest side. And the longest side is 1 inch longer than the side that we know in question. And so we can say that this is x plus 1. And so one of the things that I'm going to give you some problems and want you to practice a little bit is looking at some of these circumstances and seeing if you can create some algebraic equations to look at the given circumstance. Because it might not seem like we've made a lot of progress, but since we know that the perimeter is equal to 17 inches, we can say that 17 inches is equal to x plus x minus 1 plus x plus 1, and we can solve accordingly. So we see that this situation would equal 3x, negative 1, and plus 1 would cancel out. So we can say 17 equals 3x, divide both sides by 3, x is equal to 17/3 inches, or if we want to, we don't need to put it in decimal format. We'll just leave it in 17/3 inches because it's not going to be a rational number. It'll be your rational number if we put it in decimal. And then that would be your answer. So the sides for this triangle, this would be 17/3 inches. This would be 20/3. Okay, because it would just be 17/3 plus 1, so that would be just adding 3 over 3 to both sides. And this would be 14/3 inches. All right, and so we have some different skills being implemented here to look at these given circumstances. So hopefully that gives you a little bit of perspective and a good example that you can refer back to when trying to analyze some of these types of questions. The next example is the sides of a triangle are in a ratio of 3, 4, 5. What is the length of each side if the perimeter of the triangle is 30 centimeters? Okay, so we're going to look at a very similar circumstance here. So let's set up 3, 4, 5. And all I'm going to suggest here is that if you're given a extended ratio like this, again, they're telling you the perimeter is equal to 30 centimeters. All you have to do is you understand that if this is a 3, 4, 5, this is the 3 part, this is the 4 part, this is the 5 part. All right? And what I'm going to encourage you to do is just put an x with that. Put an x with each of those components. Because if this is 3, 4, 5, you know this could also be 6, 8, 10. Or 9, 12, 15. It doesn't matter what the x is as long as the proportion is held constant. So this side would be 4x, this side would be 5x, and this side would be 3x. And we can just go and implement this variable to describe the ratio, because as long as the ratio is true, many characteristics of the triangle will be. And if the perimeter is 30 centimeters, we can just simply go 3x plus 4x plus 5x. Well, we know that's 9, 12, so this will equal 12x in 30 centimeters. All right, divide both sides by 12. And then we would simply have that this x is equal to 5 over 2. And then we can plug that into this. We would see that this would equal 25 over 2 centimeters. This would equal 20 over 2 or 10 centimeters. And then in this situation, we would have 15 over 2. And you would have the sides of all of these given the situation that you're setting up here. So again, whenever you're dealing with triangles and they just give you the ratio, just put an x with each of those sides, and then you can solve for the question that they're asking you accordingly. Another situation is if the measure of a supplement of an angle is a 20 degree angle more than 3 times the measure of the original angle, find the measure of the angles. All right, so in this given situation, we're trying to put some mathematical operation here. If you don't remember from your geometry days, just remember that a supplement is equal to 180 degrees and a complement is equal to 90 degrees. So 2 angles are equaling 180, or if it's a complement, 2 angles are equaling 90. All right, and so if the measure of the supplement of an angle is 20 degree angle more than 3 times the measure of the original angle, find the measure of the angles. Okay, so we're gonna create something like this. It's probably gonna be some type of proportion. All right, let's say the original angle is x. So this is x right here. And the supplement to the original angle is going to be 3 times the measure of this angle plus the 20 degree angle already being described. So this is a straight angle. These 2 angles are supplements. The combination of these 2 is 180 degrees. And so if you have this information, you have the knowledge, what you're doing is you're taking the word problem and you're trying to put pieces of information together. All right, and I'm not saying that this is super easy to deduce. All right, you have to read the sentence carefully and deduce the information from it. 20 degree angle more than 3 times the measure of the original angle. And probably the toughest part is to figure out what that side is. All right, so if you're doing this and you're doing your homework, a quiz, an exam, you know, show me the work, all right, that you're doing. I mean, if you're setting something up and you get something weird, it'll be like, okay, there maybe was a misinterpretation and that type of thing. That's okay. What I want you guys to be doing is that when you're looking at these problems, start trying to implement these algebraic tools, because the more that you practice with it, the more comfortable that you're going to feel with it. All right, so we have this given circumstance. We can now say 3x plus 20, the one side plus the other side, is equal to 180 degrees. We can now combine like terms. 4x plus 20 is equal to 180 degrees. We can subtract 20 from both sides. We can see that 4x is equal to 160. If we divide both sides by 4, we can very quickly see here that x is equal to 40, which allows us to say that 3 times 40 is 120, 120 plus 20 is 140, and x is equal to 40. And we can see 140 plus 40 is 180, so that would be the situation that you would have given this specific word problem. So let's move on to our second skill, which is the real-world application problem I want to go through. So this one, it is a little harder in the aspect that there is more information that you have to go and analyze. So in this specific situation, I have 2 planes left an airport at noon. One flew east at a certain speed and the other flew west at twice the speed. The planes were 2,700 miles apart after 3 hours. How fast was each plane going? So to put this into some perspective, we have, a radio control tower, and there's, the guys up here going and doing their thing, and these planes are back to back, let's say. And so we have a plane here, and we have a plane over here. And with this, we have to take into account all the different information that we have present. So these planes, they're on their runway, and let's say the plane that flew east is here. It's getting loaded up with some fuel, and this plane gets loaded up with some NOS. This is just me having a little fun here. So because this plane's going to fly twice as fast as this one. And so we're looking at the situation. This plane flies east. This plane flies west. And at 3 hours, they are 2,700 miles apart. Okay, so this is the basic emphasis of what is getting communicated in this problem. So really what I want you to be able to do is look at a given situation like this and try to identify what is present. Some of you are going to have really good spatial thinking skills. You're going to be able to put together certain parts of this problem in your mind, and that is really cool and awesome. And some of you are going to have a little bit harder time doing some of that. And so I want to show you how you can logically try to work your way through this by using some expressions. And one of the big things that you're going to see on quizzes and exams are these type of examples where distance is equal to rate times time. All right, those examples are going to be present. So with that in mind, there's some things to take into consideration. So if these two planes are 2,700 miles apart after 3 hours, we can figure out what the average rate is per hour. So for example, if we just want to start writing some expressions and take this apart, we can say distance total is equal to the rate, let's say, of plane 1 and plane 2, of plane 1 and plane 2, times the time total. All right, and this could set up some situations where we could go and say, if you travel 2,700 miles and you want to know the rate of plane 1 and plane 2 times the total time of 3 hours. All right, and we should include the units here. That's my bad. We can divide both sides by 3 hours. And we can derive out that the rate of plane 1 plus plane 2 is equal to 900 miles per hour. Okay, and so there are some pieces of information like that. And I think I really want to encourage you to do as you're going through these problems, if you're taking a quiz or taking an exam, and if you're looking at a problem and you're just like, oh, I don't know where to go, do something. Try to set up these equations, even if they're not the right equations. Try to set up these equations and find whatever information that you can, because this is a really good way to get some partial credit, or you might stumble onto the answer and get all of the credit. But the thing is that many of you probably haven't had a lot of practice doing this yet, and this is something I want to work on in this class, is like, hey, how do we plug in some of these variables, and how do we look at some of this and do this? And this can be a really useful piece of information, because if you know one plane's flying directly east and one plane's flying directly west, maybe you can put together and say the rate of the west flying plane, plane 1, let's call this plane 1, and let's call this plane 2, is equal to R1 plus R2. Okay? So a really big part of this is just looking at these given circumstances and trying to figure out, hey, how are we labeling things? How can we identify some of these things and figure out what they are? And with some of this, we can go and maybe with something like this, maybe you see what the answer is already, or maybe we need a little more information. So if we understand that plane 1 is twice as fast as plane 2, well, we can take these values, we can take these variables and keep trying to attribute relationships until we can find the final answer that we're looking for. So for example, if we want to go and say, how does R1 relate to R2? Well, we know that plane 1 is twice as fast as plane 2. So if we say that R1 is equal to 2 times R2, we can show that that relationship works. And if you're ever unsure of how to apply it, well, you just test the point. So if, let's say, plane 1 is going 200 miles an hour, plane 2 should go 100. 2 times 100 is 200, and we can go and we can check some of these relationships. You could also say 1/2 R1 is equal to R2 or something like that, but it would allow you to go and find other information. And this really comes into play because we have two variables here. We could then substitute one of these back into the equation here and find our answer. So for example, if we want to say 2R2 plus R2 is equal to 900. One of the things that you can do is, as you find more of these relationships and pieces of information, I'm substituting 2R2 for R1 here and leaving R2 as R2. We know that this is equal to 900 miles an hour. And then we can go and say something like 3R2 is equal to 900, and eventually derive out that R2 is equal to 300. And we'll see that the plane flying east is going 300 miles an hour, and the plane flying west must be flying 600 miles an hour. And again, we could plug that into equation format and test that. We could go and plug that in up here, and if we know R2 is 300, R1 plus 300 is equal to 900. Do some simple operation with that and find that R1 is equal to 600 per hour. And so hopefully you can see some of that process and how I'm thinking that through. And really, like I said, a big thing for me is as you're going through this and trying to figure some of this out, I really want to see you implementing variables to specific things and trying to work through the process to solve something. What you'll see on the quizzes and the exams is if you just give me the right answer, I'm only going to give you a small percentage of the points. I want to see the work in going through and trying to understand so that we can go and try to drive that out and answer more complicated problems as we progress. And so it's really important that you go through and try to associate these variables to specific things now as we're looking at simpler examples so that we can scale that up as we're going further. But with that said, I hope that you found this video helpful and that it gave you a little bit better understanding how to approach some of these problems. And with that said, let's do some math.